Okay, so 12.1 part 2, and we're going to talk about permutations of objects. So the first thing that we're going to deal with is permutations of n objects taken r at a time. So in other words, the number of different orders of things. So the number of permutations of r objects taken from a group of n distinct objects is noted by npr, and is given by npr is equal to n factorial over n minus r factorial. Okay, so remember factorial, so such as 5 factorial just means 5 times 4 times 3 times 2 times 1. So in other words, it's whatever this number is multiplied by all of the integers below it down to 1. So example 4 says you were left a list of 8 chores. In how many orders can you complete A, 6 of the chores, or B, all 8 of the chores? So the number of permutations of the 8 chores taken 6 at a time would be 8 factorial, because that's my n, so 8 is my n, okay, over 8, my n, minus 6, my r, so remember I'm only going to do 6 of the chores, factorial. Well, that comes out to 8 factorial over 2 factorial. Okay, so if I do that on a calculator, 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, we get 4,320 over 2 times 1, which is just 2. And so that gives us 20,160 different ways that I can do those 6 chores. Now B, the number of permutations of all 8 chores, so if this time I do all 8 chores, that would be 8 factorial over 8 minus 8 factorial, which would be 8 factorial over 0 factorial. 0 factorial is one of those kind of odd ones. 0 factorial is just equal to 1. So that leaves us with 8 factorial divided by 1, which is just 8 factorial. And so we get 40,320. Okay. So now, then, the last thing that we're going to do is talk about permutations with repetition. So the number of distinguishable permutations of n objects where one object is repeated q sub 1 times, another is repeated q sub 2 times, and so on, is n factorial over q factorial times q2 factorial, etc., etc. So however many times we have a repeated one. All right, so the last example, example 5, will show us how this works. So example 5, finding permutations with repetition. So we're going to find the number of distinguishable permutations in the letters of algebra and mathematics. Okay. So for algebra, we notice that we have 7 letters, of which only one is repeated, and it's repeated 2 times. So the way that we would figure this out is our factorial, so 7 letters, so 7 factorial over q factorial, so q is our repeated letter a, so times or over 2 factorial, so 7 factorial winds up being 5,040 over 2 factorial, which is just 2 times 1, which is 2. And so when we perform that operation, we get 2,520. So there are 2,520 different ways we could rearrange the letters in algebra, and because of the repeated A, that actually reduces the number of possible ways that we can do it. Now, the next one, mathematics. Okay, so we look at mathematics. It has 11 letters, of which we have 3 repeated letters. We have the repeated letter A, the repeated letter M, and the repeated letter T. And each of those is repeated 2 times. Okay. So the number of distinguishable permutations is 11 factorial, so there's our n factorial, over q1 factorial, so m is repeated twice, times a, which is repeated twice, so it's another 2 factorial, times another 2 factorial for the t that is repeated twice. So 11 factorial over 2 factorial times 2 factorial times 2 factorial. Well, each of those 2 factorials, 2 times 2 times 2, is just going to give us 8. Okay, so 2 times 1 is 2, times 2 times 1 is 4, times 2 times 1 is 8. And then 11 factorial is a very large number, so 39,916,800. So once we divide that, 39,916,800 divided by 8, we wind up with 4,989,600 different ways we could rearrange the letters in the word mathematics.